Hello, welcome back for lesson 9.4. We're getting ready to learn how to put our hypothesis test together. And to do that, we have to know what signifies a rare event. I just got coffee everywhere. And so a rare event happens when you have typical situation, and then the next time you do that same activity, it turns out something that seems unusual. Okay. And so the activity that you should have done with your group was looking at the number of fives rolled out of 12 rolls on a die. And you would see that most people rolled between a 1 and a 4. You might have gotten something even more, but then there was somebody that rolled 12 fives, which you said that seems a little fishy, a little unusual. And so you wanted to prove that could really happen. Okay, that's a rare event. So we are going to be talking about things that are statistically significant in our hypothesis testing, and that means that they are very unlikely to happen due to chance if the null hypothesis were really true. And so that means we're going to reject the null hypothesis. So the classical way of doing a hypothesis test was using what we called z-scores. So remember back in our earlier lessons, we talked about z-scores, and we said if you were more than 2 z-scores below the mean or 2 z-scores above the mean, you were considered unusual. That is one way that some people approach this. More sophisticated statistical systems now use what we call the p-value approach. And that is the probability approach. That is using the less than 0.05. What we said back in the earlier chapters was 5% likelihood. We said that was an unusual event. And so that's what we're going to use as this p-value. So the definition of a p-value is right here. If the p-value is less than alpha, then we reject H0. Okay, so p-value by definition in your notes is the p-value is the probability that if the null hypothesis is true, the results from another randomly selected sample will be as extreme or more extreme as the results obtained from the given sample. So we have something proposed, and then we're gonna go to the court, basically our jury, and say, hey, we think that this unusual thing happened, and so we're thinking that the H0 is not true anymore. And so then the jury decides if we're going to agree with the H0 or reject the H0. And so that's what we're using the p-value for. So if we're not given an alpha, so if we're not given a level of significance, our statistical significance level is always what we call our alpha up here. If we're not given that, we're going to assume that it's 0.05. Okay, and so we're going to use that. So let's just read through a couple examples where we're just getting used to reading the hypothesis statement. It says a normal distribution has a standard deviation of 1. We want to verify a claim that the mean is greater than 12. A sample of 36 is taken, and they have a sample of 12.5. So our test that we're doing here is a right-tailed test because it's a greater than. That's something we need to pay attention to. And that's going to tell us how to draw a graph. The p-value is 0.0013. Draw a graph that shows the p-value. So on the graph, we're going to draw our 12, and then a p-value of 0.0013 would be here because it said greater than in the sample mean is 12.5. Is 12.5. And so the likelihood of another sample having an average of 12.5 or more is only 0.13%. So not likely. Okay. So our step 5 in our hypothesis test, when we put this all together, is going to be making the decision if we reject or do not reject. And remember, we said we're going to reject if the p-value is less than the alpha, the level of significance. If we reject H0, then we are going to write our conclusion in step 6 with these words. There is sufficient evidence to support the claim that, and then we're going to talk about H1. Do not reject the null hypothesis, then we're going to write, this is our conclusion. There is not sufficient evidence to support the claim that, and then we're going to talk about H1. So we're going to do a few examples. It says, it's a boy genetic labs claims their procedures improve the chances of a boy being born. The results for a test of a single population proportion are as follows. Interpret the results and state a conclusion in simple non-technical terms. So for one, let's just acknowledge, because a greater than, it's a right-tailed test. And we would usually have a graph here to show this. And our H0 is 0.5, so that's what we're going to put in the center. And it's a greater than, so our p-value is over here, and our p-value is 0.025. And so we're always going to compare our p-value on the left compared to our alpha, and our p-value is 0.025, and our alpha this time is 0.01. And our p-value is greater than our alpha, so we do not reject H0. So that's our step 5. So our step 6 would be to write a conclusion about that. And our conclusion is going to be following this up here. There is not sufficient evidence. There is not sufficient evidence to support the claim that the true let's just write that the procedure improves the chances of having a boy. So it does not improve the chances because we do not reject H0. So notice, if it's do not reject H0, then there is not sufficient evidence. That will help there. Okay, catch me back for lesson 9.5. We are going to actually put our hypothesis test together.